Good evening everyone. So today we are going to discuss Acer green and this question is related to the reactions. So look at this stem very first. So you can see aldehyde treated with alcohol and it forms hemiacetal, and if you are going to check the bonding pattern of hemiacetal, you can see a carbon has 2 oxygen connectivity. I am talking about this one. Carbon has 2 oxygen connectivity in which one is OH and one is a R, means any carbon or hydrogen containing chain. So you can say this is R, which is a carbon. So this type of connectivity is called as hemiacetal. Okay. Here you can see this carbon, one is OH, one is O again. So this is also hemiacetal. And this structure you can see, this is the carbon, this carbon has a OH, a hydrogen and O as well. So one OH, one O, this particular carbon is a hemiacetal. Clear? Now move to the next question. Which one of the following structure represents the hemiacetal that exists at equilibrium in a solution of propanol, CH3, CH2, CHO and ethanol? So this is the CH3, CH2, CHO. And this is the alcohol, CH3, CH2OH. Clear? If you look at the previous information, the reaction, you can see I am talking about the formation of hemiacetal. Here you can see, if you look at this aldehyde and alcohol, this CH3CH, this CH3CH is here same, CH3CH is same, means you can see this oxygen grabs this hydrogen and it further becomes OH. You can see CH3CH, this is OH, here you can see, and the rest of the part, this alcohol with this 2 carbon chain bonded to this carbon, you can see this carbon has OCH2CH3, which is OCH2CH3 here, and this oxygen grabs this CH. So we can connect oxygen and how many carbon? 2. So we can say CH2 and then CH3. Clear? So look at here again, oxygen of aldehyde attacks over this proton of alcohol and it becomes OH, and the rest of the part of alcohol, which is oxygen with 2 carbon chain bonded to this carbon of aldehyde, you can see. Clear? So in the question, what will happen? This oxygen grabs this proton, so it becomes CH3, CH2, OH, and this is hydrogen, you know this. And the rest of the part, this alcohol attack over this carbon, so it becomes oxygen and then CH2, CH3, like this. Make sense? So how we can select the right choice? You can see the oxygen has 2 carbon, and if you look at this option C, you can start from here, CH3CH2, CH3CH2, and then a carbon has OH, and this carbon has H as well, this CH, and then oxygen and then 2 carbon, oxygen then 2 carbon. Clear? So this is a hemiacetal product of this reaction. So we can say C is the right choice. Why A is wrong? The reason is that if you look at A, this is not a hemiacetal structure, because hemiacetal is what? A carbon has OH and a carbon has O at the same time. So this carbon has OH but not oxygen here. You can see oxygen is too far from this carbon. So A is wrong. Same with the B. B is also wrong. This carbon has OH, but again this oxygen is not bonded to that carbon. D is hemiacetal, there is no doubt. But you can see this oxygen, this is CHOH, and this oxygen has 3 carbon, and I said that oxygen has 2 carbon here. So D is wrong. Makes sense? Now 58. We have a product here. We have to figure out aldehyde and alcohol. So what is happening here in the reaction? Look at here again. This is my aldehyde and this is alcohol. So you can see oxygen attack over this hydrogen, and this oxygen with this 2 carbon chain bonded to this carbon. So as a result of it, CH3, COH, CH and oxygen have CH2, CH3. So you can see this oxygen with 2 carbon is a part of alcohol. So you can see this oxygen and 2 carbon, this oxygen and 2 carbon is a part of alcohol molecule. Clear? So we can say the alcohol should be CH3, CH2 and OH. And which option is right? This. Clear? And this CH3, CH2, CH2C, this 4 carbon will be my carbonyl, you can see. Makes sense? And you can cross check as well. If you are going to react these two, you can form this product. I'm gonna check here. CH3, CH2, CH2, CHO, and what is my alcohol? CH3, CH2, CH. So oxygen grab this hydrogen, so it becomes OH, and this oxygen with 2 carbon attack over this carbonyl carbon, so oxygen with 2 carbon. Clear? You can see oxygen has 2 carbon, oxygen has 2 carbon. Clear? Now look at the third question. We have few structures and we have to figure out which one is a hemiacetal. So let's expand, but before this structure is called hemiacetal, 2 oxygen connectivity, and any one must have OH. So if you expand the very first one in 59, CH3 and then oxygen and then CH2 and then again CH2 and again OH. So you can see this is not hemiacetal. Why? Because a single carbon has no 2 oxygen. You can see this carbon has just only 1 oxygen connectivity. Or if you are going to see this carbon, this one also has just 1 oxygen connectivity. Clear? Look at the second, CH3, O, carbon, 2 hydrogen and OH. You can see this carbon, this one has 2 oxygen connectivity, one is OH and one is oxygen with a carbon. So this is a hemiacetal. And the third one, here you can see this carbon has a 2-oxygen connectivity and any one is OH. So this is a hemiester. So second and third, so D is the right choice. So this is from reactions. Thank you so much for watching this.